Okay, so in this video we are going to do a fairly common system of equations problem. You'll see this in Algebra 1, Algebra 2, and oftentimes on standardized tests, the SAT, ACT, and you'll definitely see this in chemistry as well. So Mary mixes a 25% chlorine solution with a 45% chlorine solution. This mixture produces 55 liters of 29% chlorine solution. How many mixtures of each solution did Mary use in the mixture? So really what we're solving for is how much of each solution did we use? So X is equal to question mark liters of total solution that she used, which happens to be 25%. And then Y is equal to question mark liters of total solution, and that happens to be 45%. You can just imagine grabbing two of these bottles and mixing it together, and then you end up with a total of 55 liters. And that 55 liters happens to be 29%. So that's easy to imagine. And so if we just focus on this portion of it, you get a pretty simple equation. So you just get X plus Y is equal to T, but we know what T is, and that's 55. So that's our first equation. And then most people, when they see a problem like this, they'll say, okay, I remember from class or from my teacher explaining it that I'm going to change that percentage into a decimal, and then I'm going to change it to 0.25 times X plus 0.45Y is equal to, and then I'm left with this 50. And sometimes people say 55, but that doesn't make sense because we just use the 55 with X plus Y, so it's probably going to be 0.29 times 55, which it is. And we're going to explore more after I solve this. We'll explore more as far as why we have 0.29 times 55 and what each of these terms represents. So anyway, let's solve it first. So when we look at this, it's a system of equations problem, and the first thing we want to do is just multiply 0.29 times 55. So let's go ahead and do that. So I'll bring up my calculator. So 0.29 times 55, that is equal to 15.95. So this is equal to 15.95. And then we want to eliminate, it doesn't matter which one, we'll just eliminate the X. So we're going to multiply this entire equation by 0.25. And so we're going to distribute that 0.25 to all three terms in the equation. So actually, I'm sorry, it should be negative. So negative 0.25x minus 0.25y. And then this is equal to, and again, let's bring that calculator up, 55 times 0.25. And that's equal to 13.75. Sorry, we got the equations kind of squished together here. So 0.25x minus 0.25x, that's 0, and that's obviously eliminated, which is why it's called the elimination method. 0.45y minus 0.25, that is 0.2y. And then we subtract this. 5 minus 5 is 0, 9 minus 7 is 2, so it's 0.2. 5 minus 3 is 2, 1 minus 1 is 0. So we can divide both sides by 0.2. And so then Y is equal to 11 liters of 45% solution. And then we can take this and we can just plug it back into our original equation. X plus Y is equal to 55. So we substitute the Y. So we X plus 11 is equal to 55. Whoops. And then we subtract 11 off both sides. And then we're left with X is equal to 44 liters of 25% solution. So at this point, this is how most students learn, and that's fine. But the issue comes up when you get problems that are structured more in a more confusing way. They might say, well, 25% chlorine mixed with 45% chlorine, and then rather than ending up with 55 liters of total solution, they might say that you end up with, I don't know, 12 liters of chlorine. And then a lot of times people would mistakenly put that 12 where the 55 is supposed to go, and that's not correct. So let me try to explain this in a little bit more detail. We'll just start on the first sentence. Mary mixes 25% chlorine solution. So let's just create an equation for that. So we'll say R sub 1 is equal to 0.25 liters, and it's liters of pure chlorine. And this is over the total amount per 1 liter of total solution, which happens to be 25%. And this is why these chemistry problems are a little more confusing, because the rates in this case, they're not as obvious as rates from other problems where you're talking about a dollar per item, like in a grocery store it's $2 per apple or something like that, or 55 cents per orange, and you have dollars per orange. But in this case it's liters per liter, and that's where things can get a little bit confusing. So our second rate is 0.45 liters of pure chlorine per 1 liter total solution, which happens to be 45%. And then R sub 3 is equal to, I forget what that percentage was, 0.29. So 0.29 liters of chlorine per 1 liter of total solution, which happens to be 29%. And while this may seem redundant, I think the understanding of the rate being liters per liter, liters of chlorine per liters of total solution, will help take some of the confusion out, at least hopefully. So the structure would be R sub 1 times X plus R sub 2 times Y is equal to R sub 3 times that total amount. That total amount was 55. So let's just examine what each of these what each of these terms represent. And we can do that by looking at the unit of measurement for each factor. So for this factor, R sub 1 of this first term is liters of chlorine per liters of total solution. So we'll say liters of chlorine per liters of total, which happens to be 25%. And then this X represents how much we actually poured in. So that's how many liters of total solution that we actually poured in that happened to be 25%. And so when you look at the unit of measurement, this unit of measurement crosses off with this unit of measurement, and then you're left with liters of chlorine. So that means this term represents the amount of chlorine that you had poured in based on that total amount of solution that you poured in, because obviously only 25% of it is going to be chlorine. And so the same thing would be true here. You'd have liters of chlorine per liters of total solution, which happens to be 45%, and you'd be left with liters of chlorine. And then same thing with the final term. The R sub 3 is 29% of that 55 liters is chlorine. So when you multiply those together, the liters of total solution crosses off the liters of total solution. So again, liters, this is liters of chlorine per liters of total solution times liters of total solution. And then in this case, it is 29%. That's 29%, and then this guy is also 29%. And then these all cross off, and you're just left with liters of pure chlorine. So the unit of measurement works out. You have liters of chlorine plus liters of chlorine, and that should be equals liters of chlorine. And then in our other equation, we had X plus Y is equal to T. And this makes sense as well. If you take a jug of 25% chlorine and mix it with 45%, those are two amounts that with total solution that you're pouring together. So this is liters of total, mixed with the total liters of a different concentration, and then that's going to give you a total liters, that 55 liters, and that's also going to be the total amount of liters, not the total amount of chlorine, but the total amount of liters. So you get liters plus liters equals liters. But the unit of measurement for these two equations are actually different. It's liters of chlorine for this equation, and then this is liters of total solution. And that's a great clue as far as when it's often easier to use elimination. When you have unit of measurements that are different for the two equations within your system of equations problems, you typically, but not always, but typically would want to use elimination.